Good. So yeah, welcome everyone. So this is our second tutorial with ROS on Sawyer. So first of all, you guys all worked on the tutorials and I hope you know the basics of ROS now. And we're gonna show you how to work on Sawyer using the same 14.04 version and all those things. So Sawyer is like the collaborative robot to enhance human-robot collaboration in industries. That's how they sell or promote Sawyer. It has 7 degrees of freedom, you can see, like one there from the base to the top, like arm gripper. So it has 7 degrees of freedom, and the precision they talk about is like within the error of 0.1 millimeter, which is much more than Baxter. And Kukas are like 0.01, so that's how you can see the accuracy levels. So there are some important links, you can go through them. Wiki contains all those important like wiki files and stuff, like everything. Your papers, every paper published on Sawyer, related to Sawyer, and then repositories, how to install workstations and everything. So Sawyer Wiki essentially contains everything else, but if you want direct specific links, setting up your workstation link is it will show you how to set up Sawyer with your workstation. So you can access Sawyer with your laptop. API references is, okay, so first of all, everyone knows what an API is, right? Basically just simple commands that allows you to communicate in software, right? Like, just like as you said, services, APIs calls those services or links those services. So always use APIs built by the robot, unless you want to make any changes and that API doesn't exist, right? So otherwise, for basic commands, always use APIs. Again, going through the basics, it runs on ROS Indigo. So you'll be working on Ubuntu 14.04 and that's it. So we'll start working on Sawyer now, but before that I need any feedbacks on the tutorials or if you have any questions and stuff. If you don't have any questions, we can move on the Docker first and then I will show you Sawyer. So for ROS tutorials, do you have any questions? Everyone was good? Everyone was able to figure out? Okay, nice. So okay, finally the Docker version that we were talking about. So this is the link for my Docker image repository. So you can go there and directly clone these repositories, but I would say if you face any issue, like any form of issue with any hardware, like you can't connect your camera, you can't connect the robot, you can't connect anything else, just create an issue on the Git repository. Don't directly email me. Don't like message me or something there, because if you have a proper issue, I can tackle it, like I can systematically solve it. Because if there's no issues, I might lose the track of like what's the problem in Docker and how should I update it or not. So just create an issue, I can create a branch for that issue and work on your issue later on. And once it's updated, I'll close that issue so that you'll be notified that it's working or not working, right? So just use the issue feature in Git. Read about it, it's very helpful. Use the issue feature and just keep me updated if it's working or not. So I'm talking about like the basic Docker will work for sure. I make sure that like the basic Docker will work. Read the README file before running Docker. Make sure you have the latest updated README file and read that. And yeah, you'll be able to build the image and everything. But for hardware, you might face some issues because I tried it with only Sawyer right now. There are a lot of other things, and if you face any issues, just let me know. Create an issue there on the GitHub, and I will try to solve it. Maybe if we need to meet, we'll come together, sit and like solve that issue and close it. But just create an issue on GitHub rather than just email me. Always download from the master branch. Right now it's only one branch, master, but in future, whenever there are issues and something, I might create different branches. So my current repository or working one might be different. I'm not very good at updating my current repository regularly, but I promise the master will be the working one. So always download from the master one. Never download from any other version if you are planning to like run it. If you want to help me debug or something, go ahead and download from the other branches. But master branch will always be working on the most updated version. So yeah, if anyone wants to help me with that, like just keep creating issues, and no one will get the publishing right now, so you won't be able to publish it on my, or like commit it on my repository. But if you have any changes that you think is important, again create an issue, or just let me know if it's like something that's not an issue, just like a suggestion. So there's always a suggestion or something, just comment it. So you won't be able to commit it, but just let me know if you want to make any changes. And yeah, that's about it. So soon, like our RL repository, I'm working on creating Docker images for particular robots. So what that will do is create interfaces for all those robots if you just run those in like Docker images, right? So it might take me a little while, and it won't be published on my GitHub repository. So we'll create a labs GitHub repository, and we'll have different repositories for each robot, which will have the same structure that I was talking about. So you can just download that or pull that and work on it. So hopefully that will be updated by end of November. Like, it's gonna take me a long time because Docker image with each robot, I have to test a lot of things and make sure all the interfaces are working. So don't rush into things. It will take us a long time. Like Ivan and I would try our best to create like best README files and stuff so that you guys could work on it, and anyone could work on it actually. So yeah, bear with us. It's gonna take a little while, but after hopefully by November end, you will have access to each of the Docker images for particular robots. Like we'll create Docker images for Sawyer, Baxter, Turtlebot. So what this will do, run the image, it will create or set up the Ethernet communications for your laptops and stuff, because we'll run that as a sudo, and you're good to go.
But also, the sooner you start working on something,
yeah,
the sooner we know what are the issues, the sooner we'll be able to fix them. So if you don't work on anything, on any of the equipment, we'll be focusing on other issues that we think are important.
Yeah.
So basically, it's a kind of feedback loop. If we don't hear from you, we're not going to be like working necessarily on these issues first, because we have other things to do as well.
So yeah, if you don't run Docker, if you go back and if you don't work on like trying to interface it, I might never figure out what's the error, because everyone has a different thing that they want to work on. Let's say he's facing an issue on the Turtlebot field that he was talking about. I never saw that issue, but it's a valid thing. Like I have seen that X server could stop sometimes. So that might be a thing, but still we don't know. So if he's working on it, he knows that issue. Similarly, you'll work on Docker, you'll figure out that your camera is not working, or this robot is not communicating with Docker, or Ethernet is not supporting. A lot of issues will come, I agree. But just start working on it, keep publishing, like keep creating those issues. I'll try my best to solve them with time. Okay, so let's go on the Sawyer now. First thing. So this is the repository for our Sawyer. So you can see we named it, like it's the Catkin workspace, and we named this ROS workspace. Like go through the Sawyer tutorial, it's exactly the same way, so that you are aware of what we are doing. And here you can see the structure: build, devel, intra sh, src. So what does intra sh do? So let's see. So you can see intra sh is taking your host, like IP address or your host name. It's taking the robot host name and starting the communication. It set up all your communication parameter. It sources the repository, the ROS workspace repository, to your bash RC file when you run this intra sh, right? So the idea behind intra sh is once you run it, your configuration is done. Like you don't have to worry about sourcing it again, like sourcing your repository again. You don't have to worry about what's the IP address or what's the host name of the robot. You will directly set up the communication. It will take care of like Ethernet communication and make sure everything is working. But this is intra sh provided by Sawyer. So this is their script that we run every time. Similarly, Baxter has their script that takes us to their workspace. Like it's their workspace now. So when I go outside, do you see intra HTTP local, the first part here? This one? You see that? So this shows that you are in the workspace of Sawyer. RL. So RL Sawyer is the name of our Sawyer. So that's how you know that you are connected to that part and it's running right now. So now you can just enable, like it runs the ROS core also by itself, so you don't have to worry about the ROS core running again and stuff like that. So this is like a feature that enables the robot. So whenever you run the script, the first thing you have to do is, go there and type this command to enable the robot. So once you do that, you hear that clicks, robot enabled. So robot is operational state now. It's giving you ROS topic and all those things. Yeah, too big, right? So this is every topic that the robot is publishing right now, and your laptop is communicating to it. So you see all the topic: ROS, lim, write, command, end state, endpoint state, join command, join state, lim state. So everything, like these are all the parameters that you can work on with. Like some datas are just read only, some topics are published, like you can publish on them. So these are all the topics that you need to worry about. That's why it's ROS topic list. Don't type RQT here, like graph here. You will be like a lot of data at the same time if you want to see. Yeah, that's what I was talking about. So a lot of stuff. So this is something that's just like nodes only right now, right? So now the topics are also there. So you don't want to go there right now. And that's what I meant when you want to work on specific thing. Go on ROS topic, echo, publish. Those commands are useful now. Because now you can work on specific parts. Because everything right now on my face, I can't figure out how it's working or how it's communicating. Sometimes it's just useful to use the terminal and use that commands. So now technically how the Sawyer works is, it has those scripts. So SDK is just their repository. Okay, so these are some by default scripts or scripts provided by Sawyer. So you can just like use them and run some specific commands or something, like let's say run this. So basically this runs a particular Python script which allows us to, so basically it's like a spring command which creates a damping function of Sawyer and creates like a pseudo spring configuration. So each joint is like acting like a spring command. So it tries to go back to its initial configuration and you can move it with your force feedback. So what it does, it uses these small changes. So these motors are, all the joints in Sawyer are force related, and they measure the changes in the position that you try to give. We can change the stiffness of this, so basically how hard it should react, like should it be hard enough or should it be easy to move. And we can change the damping coefficient, which makes sense, like how faster it will move back to its own position and stuff. So yeah, this is like a default version they have. We create this, like we run this, and now the robot is like in the spring mode. We can move it, it will come back to its own position. So we'll go through the script that how the Sawyer enables this particular part. Like I'll show you what commands they are calling, what APIs they are calling, and how they are doing it. But at the same time, you will figure out that while you're running, that you can't really touch one joint to the other joint. And anyone know how they do it? Like anyone? You might have worked on URDF by? Yeah. So do you know how URDF are defined and stuff? So next stage would be working on ROS parts like URDF and spawning the robot, creating the robot model itself. It's like intermediate or advanced level, but that's how they define it. So you can always define a collision space, which essentially means that after this part, it's a collision space, and the robot won't go into that space because it's the collision area. So our joints are still this much, like the diameter of this joint is defined in this much, but we add an additional tag to that URDF called collision space. So it creates an extra, let's say 0.5 millimeter circle around it, or like the error, or like additional space around it to tell us that that's the collision space and we can't do it. So for each joint you will figure out it can't do it, because each joint has a fixed amount of collision space that they define in URDF, and the robot now reads from that URDF and agrees that yeah, that's our collision space, and we can't do that. So that's how it works, like that's how it calls and everything, but let's go through the script itself. Everyone can see it?
Could you make it bigger?
Let's see. Is this good? I mean, I'll zoom in right now, but let's see.
You can select them
Yeah.
so that it
Yeah.
will get highlighted.
Alright, this looks good. Cool. So first of all, import stuff. So what this is doing is it's calling the libraries and stuff, and what you need to worry about is first of all the standard messages. So these are the messages by ROS itself. You know, the standard messages is the ROS package that they are calling here, like ROS messages. It's nothing related to Sawyer. It's ROS thing. Then they have intra_interface. This is the APIs for Sawyer. So these are the basically this is the API that you call to call all the other functions like close, open, and all those stuff. Now Python, everyone knows, they create a class here called join springs, which is our function that we want to do. They initialize it, and how they initialize it is they set up parameters like rate, miss commands. All those are like how to set up timeouts and stuff. Those are safety features and the communication features. And yeah, here then they create these like damping springs and start angles. So these are the initializing parameters, like what should be my damping coefficient, what should be my spring values, and what are my start angles. And you'll realize that in further down the start angles and stuff is just called by the URDF or by the home position that we already stored, or the Sawyer has it in its background. Never change that. Never ever change the start angles. You can change damping, you can change spring coefficient, but please never change the start angle, because in that sense you are shifting the home position somehow. And you can technically change it and home position still be the same, but I would recommend not to change it unless you're like any one of us is there, because yeah, you need to figure out that your start angles are good, because it will move to the start angles, and when it moves to the start angle, it doesn't read through the URDF, it just moves the joints directly there. So if the board or the platform you're seeing, the URDF don't know about that platform right now, so you just go and hit that, right? So make sure never change the start angles unless it's extremely important. Start from the home position, add an extra command to go to that position if you want to go there. You know, don't change the start angle. Again, like it's calling the, so cuff is basically, you can hold that cuff here, these things, and publish it. So press the buttons, it disables them so that you don't mess up with all those things. And verify robot is enabled. So here you can see that it literally looks for that part that we're talking about, enable robot. So include this part, the small hashtag verify robot is enabled in all your files. If you want to work on this, please include all these things. Like, there are some things that you should follow every time. If you don't do it, it will start running it, robot is not enabled, you'll face issues like, it won't start anything, but now you don't know why it's not working. It won't give you the error robot is not enabled, because here that's where it looks for. So do that now here. Update parameters, it's again like, so it created the instance of parameters and then it's updating them. So this is how you give those parameters or change those parameters. And you can see you can only change spring and damping. It's not allowing you to update the start angles. So if you go to the Python file again, you can technically change the start angles by giving the values when you create the instance. But in this case, they are allowing you to update springs and damping dynamically. This is how it works now, how it updates the forces. So first of all, again, disables, make sure that it's not doing anything. Then the commands are in the dictionary format. Now you give the current position. It reads from the current values. It's dynamic current position. So when you change it, these parameters changes every time, and it reads it every time you run it. So here you can see records current positions and velocity, and then so start angles. It refers to the start angles all the time because it wants to make sure how far it is, where it should move, and all those. And set joint torques is, so these set joint torques or something, you will see sometimes they might not be here in the Python itself, because they might be calling it for the APIs that we just imported, right? So some commands like open, close, all those things, or move, they are calling those from APIs. So don't shock if you don't see such as like set joint angles, set joint dots, because they are from APIs. Move to neutral position, again if you call this command, it will just move the robot to the neutral position. This is all initialization right now, just make sure. And now attach springs, giving those spring constants to each of the joints and stuff. And update force and all those things. Okay, so now how it works. So first of all, everyone understand the initialization. I went through really fast, but do everyone like know what we are doing here? Like why we are doing here? Like this def initialization, each limb is very important. And right is just because we are working on one arm. So it's the right limb. Any questions first of all? Before moving on, how it's updating and all those things. You get it this one, right? Control parameters. You saw it in the Turtlebot tutorial. I'm pretty sure you at least saw the rate part, not the Python file, but you saw the rates, like how it's communication with ROS states and stuff. Miss commands is just like how to trigger the execution, like nope, it's not communicating anymore and how to stop it. So it just sets it to 20. Like if they miss, so ROS time publishes every, like you have the ROS time and you see when the commands are published, right? When you see echo the topics, you can see how the topics are published. So if it misses 20 cycles of that, it will stop communication, stop the flow. And spring, start angles, cuff disabling, make sure the robot is enabled. So the thing, if you want to work on your part, you have to make sure is control parameters, limb if you want to control all the limbs, which you definitely should because that's all the robot is right now. So you're going to call this part. You don't need this part unless you're going to the spring, like you want to run this part. But start angles are important, so always call the start angles. And cuff disabling, if you don't want to have the access to the cuff is that small white part you can see there. This is these buttons. Yeah. So it disables that execution, which is something that I need. I don't want them to be enabled. You can just keep it enabled. It's not going to give you any issues. And then verify robot part. So these three things: control, create your limb instance, set your start angles, cuff if not necessary, verify robot. These are very important. Make sure you include all these ones, at least these ones in your file. Update parameters depends. You might have different parameters. So let's say for me, if I'm working on the Baxter gripper, I update the parameters that I'm reading from the sensor. So I created another, like when I do self._rate, self._miss commands, I also create force values. So here the force or the capacitance that I'm measuring is from my sensor. So I keep on updating those parameters, and those parameters are published on the topics. So it knows how to read it. So whenever you want to interface anything else, you include that. Like this is something that you are doing. You can always create a variable and update it, but this is like a professional view. Update parameters, I just call that part to update because I don't want to update anything else. It's just my gripper part, like sensor values. So now when you do forces, like calculates the current angular differences between start position and current joint position, applying the joint torque split forces as defined in the dynamic reconfiguration server. So you saw the dynamic reconfiguration server that we call here. To be fair, I don't know deep inside what this server is doing. All I know, it measures the position difference and moves to that position. So if you want, you can read more about it. So what it does is basically, where's my current position, where's my home position, and how far I am. It just calculates them and what torque it requires to move from one part to another part and executes them. So you always have to run this. So it always runs because you call it here from the server. So what we are doing it here is we are measuring the current positions and changing it, like calling the dynamic server, so it moves there. Move to neutral is something, okay, let's say about this. So what do you think move to neutral is? Service, topic, or message? What do you think? how move to neutral will function as a service, as a topic, or as a message. As a service, yeah. So you call this service and just like executes the command of moving the Sawyer to the home position as we talked about. Attach springs, now it's like creating the instance or like giving out the values and stuff. Update, like it's here, this is the loop where every ROS commands are running. You can see this loop, right? This part here. So it updates the forces, it calls this function basically, and it moves the robot there. Dynamic servers move the joints there. So that's where the execution is going on, like new dot is given to the ROS command, like ROS publishes it kind of thing. And what else? So this is like again going into deep like how Python works itself. Just creates like once you have the class and stuff, it's gonna create an instance of this class and gonna call all those parameters and stuff, and logging and stuff. So okay, these are something that you don't have to necessarily worry about unless you are creating like it's like final touches, like log itself. You can see the log cannot detect anything. These are good for debugging. So if you want to do it to that level, they are using this just to make sure of that. So we use this error, ROS error is another thing that you can use in your Python files. So sometimes you use it for debugging, just publish it. Like sometimes you publish stuff but it publishes in the same font, but when you do ROS error, it publishes in red. So when I program, I just add ROS error instead of ROS publish. Very bad execution, like you should not do it like that. But at least when the script runs in the terminal, it publishes in the red line that this is done. It publishes it as a ROS error, but it's not an error. I just like want to check my status and I just publish it in red so that I know it's working, you know, like it passed this stage because it printed that error. I just said it's error, but it's not error. So it's like debugging tools in ROS, you can just figure it out. Log messages is more like it, whenever you close, you realize that it saves in a ROS log file. Have you noticed that? There's always a log in ROS. So that log takes care of when something went wrong, how, like every time you run a launch file or script, there is some log file there. There is some log publishing in the professional ones, like these ones. So if you mess up something, we know you messed up because we can always go up and read the log, and log is inside our system. It's not in your repository or something. You know opt ROS, right? So that's where the log is saved. So if you like don't use the robot without our permission or something, like if you use the robot without our permission and if you do something, the log will save something like that. So we can always go back and check the log. I mean, we are not saying we just want to do that, but that's how it works. Like that's how you create logs and stuff sometimes. And I mean, yeah, it's like essentially you can go through all of them, how the server is working. I don't necessarily know that how the server itself is working. I just know that if I publish the difference in the angles, it's going to take care of the joint dots and stuff. So, do you have like any specific questions on this? Like, how is it supposed to work, or what do you think you might be doing in your scripts?
Does this sound have any singularity?
Yes, but
Is it near the URDF, or is it taken care by the URDF?
no.
No.
So, okay, that's like, first of all, you guys know what the singularity is, right? Before going into that. So the idea is there are singularities, but if you would have remembered, like singularities will occur if you give a particular angles to the joints, right? Like if you give it straight angle, these two joints are parallel, now it knows that which one to move, it doesn't know, so it stops. It's like computational singularities, it's nothing related to it. But how Sawyer saves its point, you will see, is two positions. Sawyer is saving or moving using positions as parameters. Like it doesn't care about the relative angle movement, or let me put it, like it knows two positions, like it knows the initial start angles, it knows the final angles. Now it takes care of the motion here. There might be a singularity in middle way, but it's the kinetic planner of the, or kinematic solution of the Sawyer itself that moves around that singularity, so you will never stuck in singularities. But for KUKA, you will stuck in singularities because KUKA moves each joints as per your angle, so like incrementally. It doesn't plan. It can plan between two positions, but you can go into the KUKA function when you move to the joystick or something. It moves each angle as per your motion, right? So let's say I can control each joint one by one, like move 10 degrees, 10 degrees, 10 degrees, 10 degrees, 10 degrees. If I give it incremental enough, it will come into this stage and be stuck there. Like it gets stuck there because now it doesn't know which angle to move from there. But Sawyer is just saving two positions, like it's discrete movements kind of thing, so it takes care of that part.
Which means you will not be able to do the joint tasks, is that what you're trying to say?
You can do that. Again, you can do that. You will be able to go into that. But for basic functions like this one, you see it always like saves two angles, like initial, final, initial, final. So that's how it works. Like it takes a reference value and moves from there. So it knows that okay, this is my home position, this is my other one, and there might be a singularity in between, but I don't care because it will solve it itself. Like it knows that there is a singularity there, so it won't go into that area. But if you try to move it manually, you will stuck into singularity for sure. If you like start publishing it on one by one, like 10 degrees, 10 degrees, 10 degrees, and move it to singularity position, don't try this because we have to reconfigure the robot again. That's what we have to do every time if robot stuck into singularity. Even with KUKA, we have a by default function that if it's in singularity, it runs all the joints again. So basically, it moves each joint one by one to get out of that singularity and like calibrates it again. And that's the same thing with this. So there is a calibration function that we can call, and it has to calibrate it again. So don't try to go into singularity. If you by default in singularity, we might be able to go out, but we don't want to keep on getting the robot out of singularity for no reason, right? But yeah, you can technically go into singularity if you start publishing angles one by one. But if you use these commands, you would never, because you're giving. So I would say if you don't want any precise job, just give initial, final, initial, final. I think that's how also like you guys did your project. Sorry, it's out of context, but they were working on Baxter and they were playing tic-tac-toe, right? So you were giving two positions, like initial, final, yeah. So when you do that, like you have two discrete positions, it's much easier for the robot to not stuck into singularity. It will never stuck into singularity. But if you move it by angle, and you deliberately, sometimes you know which angle you are moving, right? So before moving the robot, as per your desired angles, check if that's a singularity position or not. And I hope you already know what's a singularity is, so you can always check it. Make sure no two joints are parallel. Yeah.
Suppose if I wanted to pick up an object, what is the general procedure in the board?
So again, if it's not hard-coded, you want to do image processing stuff, then you usually have a tag or something. So your camera will use that tag to detect the position. So now it knows the position in world coordinates or camera frame coordinates, and it moves to that position.
Automatically,
You have to give the command. You can give the command for positions, right? Like you can give the commands in world coordinates, you can give the commands in joint coordinates, so angles also. So if you give the commands in positions, like the world coordinate positions, it will move to that place. It's end gripper. So you can see here, let me call the ROS topic again. Endpoint state, could you see it? Like, sorry. Now we are outside that window, sorry. Yeah, basically you can give endpoint state to the robot. So here, this endpoint state.
So in other words, we don't want to compute inverse kinematics.
Why do you want to do that? That's the whole purpose of using ROS, because you don't want to create the kinematic model of the robot again. It's already been done by the company, just use that. So all their topics and stuff, they are using those functions, so you don't want to worry about that. I mean, some people do that because they want to have a better control. So if you have a system that you think like your kinematic model would be much precise than the one provided by the company, let us know. But I don't think it's gonna work. But maybe if someone wants to do a project, like I know a couple of people who are working on KUKA in my undergrad university to find the kinematic model of the KUKA itself. But their purpose was more like if they know the kinematic model of KUKA, they can create it in ROS. Because right now there is no kinematic model open sourced by KUKA, so they don't know about their kinematic model, right? So you can do black box analysis or something. But yeah, the whole idea is don't do kinematic analysis, just give positions. So end positions, final positions, all those things. So find the position first using the AR tags or any kind of vision tags, and just move it there. So then you can do the gripping as well. Okay.
So the camera built in.
Yeah. So there's one camera here on this one, and then we can always attach more cameras. It's not a big issue if you want to do any project. But yeah, this one doesn't have a grip one. There was.
No, there isn't on the side.
So there's like a one wrist camera here. I closed this screen, sorry. But yeah, this is like another camera that you could use. But these are not depth cameras. Make sure of that. Like this will give you the position, but you need to know the depth now. And I don't think you're going to do the stereo vision and stuff. So unless you just want to use it for basic, we have a Kinect. Just let us know. We can mount the Kinect somewhere, and you'll get the depth and stuff. If you can see the Kinect is there. But if you just want to know the 2D position, like X and Y, not Z, you don't worry about the Z. These cameras are good enough. They are not depth. Technically, there are two cameras you can calibrate depth and stuff, but I would not recommend that.
Excuse me. So how will you get the position, like if it's tracking a keyword tag, for example, from the camera, so how will you get the position in the world coordinate frame?
Because you know the position in the camera coordinate frames, and you know the transpose, you know where your camera is.
Okay. So we have that inbuilt function, or we
No, you have to
it?
do it. Yeah. I mean, if you are using external camera, you have to do it. If you are using internal camera, there might be one. I don't know if there is one or not, but I'm pretty sure there will be one. Because they always calibrate their internal camera at least for that. So, but if you are using external camera, you need to know the position of that external camera. So usually people mount it on their gripper because now they know where the hand-eye camera maneuvering.
Yeah.
So that's how they know that kind of like transpose between the camera and the world. It's complicated. Yeah, that's how they do it. So it has, again, force torque sensors. You can measure the force on each joints and stuff. Based on those values, you could do some cool projects. Like for KUKA itself, they use it for drilling. So for some of the car manufacturing systems where the drills are very long, you can see some of the like crankshafts and stuff. They're like very long drill and thin drill. So that's why they use their force calibration parameters to make sure that the angle is correct and the drill is not facing any external. Like it can break in the middle way, right? And you don't want it. Drill is costly, part is costly. So that's where they use these robots. Not this one. This is much more precise than what they need for that. But again, that's why the joint forces are important. For us, more like human collaboration. Like my aim would be to figure out if there's human nearby or not. If I touch it, it should stop. Or if I'm trying to push it, it should know that external forces applied. So dynamic server is doing that part. Again, measures the changes that you are giving me based on the external forces. Gives you the torque. But scripts, it's just Python. Like I'm not very good with explaining how Python works, to be fair. Like it's programming. But if you face any issues, I can.
.sh file?
What?
How do you run the .sh file?
Script? Just / any script. Like how do you run a script?
Yeah, it's just the dot /.
Yeah.
So you should cd into that and
Yeah. You cd in that folder and do that. So now I'm outside that script. I ran that script again. /intra.sh. That's it. But again, before anything else, before closing this robot, make sure you disable it. If you don't do it, we are going to have a lot of issues then. If you just don't disable the robot and switch the power off, it's going to save those things as like errors or something, and it might not give us errors initially, but with time there might be some default like errors accumulating here. So just every time please make sure that you disable the robot first before closing it. Like it's just a tutorial on how to use Sawyer, but some practices that I think Ivan already went through, that if someone else is working in this lab, make sure you don't mess up with their part. Like if you by default have access to some repositories, let us know. We'll make sure that it's not like accessible to you anymore. And always disable the robot. Always make sure everything else is closed. Always make sure the system is perfectly in its original position and shut down it before leaving. Don't leave it open. Don't leave the robot enabled. Don't close. Don't power off the robot enabled. Make sure everything else is back in the state you get it. Again, final thing is the safety button. So it's very important because you'll find most of the robots have the safety feature or safety button. So if the robot goes uncontrolled, you don't know what to do, press it. That's it. Just simply press it. It will stop the robot at that state. Stop all the access and stuff. You'll perfectly fine. Don't worry. Then just call us, one of us. We'll just like enable it and bring it back and configure it again. But always press it if something goes wrong. Like don't hesitate on pressing this button, but we don't want anything else to be messed up. You can always do that. You can configure robot again. Right now it's not deconfigured because it was disabled, but always make sure press this button if you face any issues. Like if you think robot is going out of control or something, just press it.
And it's general rule
Yeah,
for
all the robots, yeah. Yeah, don't just like keep on saying that, oh, let's see if it hits it. It might not, but be safe and stop the robot there. Like don't panic and control C here. It doesn't matter if you control C there, right? Like sometimes the messages are published, the robot already read through those messages. If the dynamic server is smart enough, it might stop, but it might take a long time. So don't panic and just like stop trying to work on computers if it's hitting something or if it's already started pressing. Just use this. Like if you panic and just like starts moving on Control C and like stop, exit, all those things here, go outside the script, doesn't matter, the commands are published before. Some things which are like dynamic, they are reading it again and again, they will stop it, but some things might not stop. Usually you should not face any issue, but always be careful where you are moving the robot. Before running any command or before running any script, test each part of that script. Test each command, like let's say you want to open the gripper, test outside how you open and close the gripper. Don't enable in the script and run the script first. Just test like, okay, this is the API, this is the service, how do I call that service? Outside, how do I call the service? Inside there. Like run it outside, then run it inside the script. Scripts runs in one. Outside you can always control the phases. It's like general control things. Like again, if you will go through the tutorials and training part of this, we'll tell you and you can show us. So, okay, now is the most important thing, how to get the access for these robots. I think Ivan already talked about this.
Well, in general.
Yeah. So now if you want, like, I would again recommend start working on these robots. You'll face some issues and we can't solve them unless you tell us that you're facing those issues. So go to the RRL website, go to our web page there, go to the robot page, you will find the links for tutorials, like how to get access to the robot. Go there, follow those tutorials, and we have a certain specifications that you need to show us a demo of the robot in RWiz or Gazebo. Okay, so move it or use Gazebo, but you need to show us a particular demo. Once you show us those demos and we can see that you can configure this robot using the workstation setup and stuff, we'll give you the access to the robot. And then you can book it, reserve it, and work on it. Like we'll create all those accounts. You can always use your own laptop. That's why I recommended using it, like dual booting it, because now you have Ubuntu on your machine. Much more easier to use your own laptop rather than system like our lab's robot. But if you need power, go with it. Like if you don't have graphic card and you want to use gazebo or something, go with it. Same thing if you want to show us a demo, but if you need a power, like gazebo is not running on your laptop, we have 2 workstations, you can reserve them. I think you can reserve them directly right now if you have the access to the lab. So
Yeah, and if you haven't tried reserving anything, just give it a try. Reserve something just for test. You can delete it afterwards. I just want to make sure that you can do it, because I think you might be missing some kind of either access or an account that I forgot to add you, and it's very easy to fix for me, but I just need to know who is missing what. Okay. I think for students who already used equipment here, it shouldn't be a problem, but for new students, that's definitely might be the case.
So yeah, do that, but start working on it. Like you won't face any issues unless you work on it. That's it. Or again, ROS is something that you will keep on learning. I'm not like very good in ROS. No one else is. Like we just learn from like whatever we are doing. Like very shitty coder for sure. So don't worry. Like start working on it. You'll learn. And use terminal again. Like don't use Windows. Use Mac. It's like try to use Linux as much as possible if you want to work on in robotics. Anything else? Okay, any questions?
It doesn't have any obstacle detection sensors.
It has.
It has?
I mean, force sensors are obstacle avoidance.
Like ultrasounds or...
No. Like, so ultrasonics are useful if your robot knows that none of their part is going to come in front of them.
Yeah.
Ultrasonic is just like it tells you something is there or not. It doesn't tell you what thing is there, right? It just tells you if something is there. These robots or any manipulator you will see, it moves around, it has like, for sure it's going to meet some ultrasonic sensor somewhere in the way, and it doesn't want that. Yeah. So force sensors are the collision avoidance. Force sensors and the fact that it has a collision checker. For itself, like the collision within the robot, it uses the URDF collision tag. Go through it, read the URDF, it's very interesting. Like it will change your perspective from SolidWorks to how robots are modeled in software. It's the same thing, but again, it will change your perspective, like how really robots are modeled. DH parameters, you're reading through it, right? So URDF will give you a much more detailed, like why do you need those DH parameters? You'll figure out once you start working on URDF. Like axis, arc, roll, pitch, yaw of all the joints and stuff. It's very interesting. Like I like working on URDF. It's very hard though, but it's fun. The gazebo parameters and all those. Like URDF is a vast thing. Now they are using macro instead of .URDF. So that's another, they have like much more features that you can call or do math inside those URDF funnels. So it's very fun. If you face any issues in the URDF, let me know, but URDF is usually when you have your own robot. If you're working on these robots, they already have their URDF, which is the robot description. Don't change them ever. Don't change them ever, because they know how to configure their robot. Don't be like smart as there and just go up and change their URDF. You can technically change it, but don't do that ever. Like, it's their description file. That's why it's deep hidden inside. You can't even like directly find it. But if you ever find it, don't change it ever. URDF, don't change it.
So if like we're adding a component, like for example a camera above the wrist, so and we want it to be in the
Then you
URDF,
change. Then you don't actually change the URDF. You add another one. So that's how macro comes into picture. So what macro do is macro allows you to add 2 URDFs. So you just create another macro file and tell us create a pseudo link, and this is your camera URDF that you already got from the open source platform. This is your robot URDF that you got from open source platform. You create a pseudo link that links both of them. Pseudo joint that links both of them. It could be a fixed joint. It could be a rotational joint. But there's a pseudo joint.
But like, how will we tell the position?
So first of all, you know URDF.
Yeah.
Okay. So in URDF, you always know parent link and child link. Do you know about that?
Yeah.
So there's the parent and there's the child link. Do you know that each child can have only one parent, each parent can have as many child as possible? That's very important though, because you're gonna mess up with that part. So if you have a parent link, you have a child link. Now your parent is the Sawyer end state, and your child link would be connect base. And this is the pseudo link that you created. And this link, now this link is just, it doesn't have dimensions, it's 000, XYZ 000, and type of link is fixed. Instead of rotational, translational, it's fixed. So you give those tags their fixed link, positions and orientation 000, which means it's directly connected to this part. So now it configures everything by itself and it knows the position. It's okay. So yeah, that's why macro, you use macro now, because URDF, you have to edit the URDF, but now you don't have to edit the URDF, you can just use macro and attach two URDFs together. It's much simpler. So you call it like import macro, this dash 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 dot macro, that's it. Import dash 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 dot macros. Both the macros import now. You can call it and run that specific. Now the new macro file that you created, run that macro with this. Now it's calling both of them, connect and URDF and connecting them. That's how we do it.
It's all words though, but once you reserve
Yeah,
it
yeah, yeah.
and like, you know, you ask a question and the Rishabh will help you, I think it's going to like.
Yeah, I mean
much
right now
better.
no one's gonna understand what happened here because 100% it's not gonna work when you try it for once. Pretty sure 100% it's not gonna work. Because you will mess up with a lot of other tags that are there. Gazebo won't run because you forgot to give gazebo tag. Inertia, you have to define inertia. So a lot of things goes into each of the joints or each of the URD parts or every part here. So start working on it. Unless you work on it, you won't understand it. Like that's the ROS thing. Like you will forget it. You will forget all the tutorials in like 1 month at max, and you will start again if you don't work on the robots. So start working on the robots. You will remember it. You will keep on building on it.
Do you understand correctly, if your DF is not properly set up, and like, let's say there's a camera, the camera runs into something, the robot is going to lock itself because of the force sensors.
Yeah. So if there's an external force for each of them, they have the dynamic server again. It looks at the forces all the time, right? And if it exceeds, it stops there. So it will do that for sure, yeah. But always before running the robot, we can run simulation. So if your URDF model is correct, it will run perfectly in simulation. Like it will show you in RWiz that the camera is connected to the wrist in RWiz also. So that's why we are asking you to show us a demo on simulation, because if you do that, it means we are perfectly fine and you can run the robot. That's why ROS is good enough. Like topics are same when you run the simulation or the robot.
So if you wanted to use crazy fly instead of Axel robots, how do you get access?
Oh, it's the same thing. You have a ROS part and Crazyfly has some packages. I think I will update the tutorials on Crazyflies.
I don't think we have any currently. I don't think it's listed on their website. I mean, we have it says that we have it. It's a Nano Center scheduler. So basically, but treat any equipment that you see here the same way. Like if you want to get access to anything, even if it's not listed anywhere, because some of the equipment we have, it's not unpacked even. Like we have a couple of sensors, vision sensors that weren't unpacked yet. Just email us and like basically we have these robots which were donated. You know, if you want to use them, it's fine with us. Just email us and we'll figure out how you can use them.
Yeah, so for Crazyflies, I'll work on them and update the tutorials.
Yeah. But you see, that's the thing. There are so much equipment. We cannot. We say we will work on that. We cannot work on all of them. So the only way for us to work on the thing that you I think is important is for you to address us and say, I want to work on that. Then we'll put it as on top of our priorities and work actually on that. Because Rishabh probably told like 10 times today, I'll work on this particular thing. But he's also a student, so he doesn't have the infinite amount of time. So, he'll probably finish all those things, but within a month or two. And if you want to work on, let's say, crazy flights tomorrow, the only way to do that is to actually poke us and make sure that we do that.
Yeah, if you just like force me that no, my project is due tomorrow, I can't do anything else. Like I have to make sure that the crazy flight is running. So, okay, so I'm just gonna go through small thing of. Sorry. So I'm just gonna show you the Docker part and how to run it, so that you guys have the access. So you can disable the Ethernet and stuff, but always remember to enable them again. Alright, so it's already mirrored. Cool. So this is the repository that I was talking about. By all means, it's not completely my work. Like I took some work from someone else, I took some work from someone else, open source platform built on it. But this is the version that we are running now. So essentially, it will allow you to run 14.04 in ROS, Indigo in ROS, in Ubuntu 16.04. Doesn't matter if you have inherit ROS or not, it will run. So all you need to do is first of all install Docker CE. I'm not telling the way how to install Docker CE because you can Google it. Like install Docker CE. That's all you need to do. Just install Docker CE perfectly and run Docker daemon. Remember these two things, that install Docker CE and run Docker daemon. Make sure Docker daemon is running right now in your terminal. And then once you do that, go to the repository cd in that and build the image by the name like sudo build sh image name. You can give any image name, like I usually give ROS Indigo to make sure my image is correct. So it will take a lot of time for the first trial because it installs all the things, like it downloads the complete Ubuntu 14.04, downloads ROS Indigo there and other packages that are included in there. You can cancel it, once you do it, you don't have to do it again though. Like you don't have to build the image again and again unless I change the image. And I'm not going to do it that often, like unless there are issues and stuff and updated it, you will build the image again. But the first build is going to take long. All the consecutive builds are much easier, much shorter because I will update it layer by layer. So the first build will always be there in your system. Whenever you build it again, it will just update layer by layer. Read on Docker, you will understand that stuff. It's crazy amount of work. But a lot of people will tell you it's bullshit, but it worked for me. Like a lot of people face a lot of issues with ROS on Docker and they won't recommend you, but I'm working on this for long now and I think we have something that you can use, so just try to use it. And build that image and then run that, like run the image, use that. Now you will be able to go into the Docker, it will run by default and it will be in your sudo. So you'll see the sudo -- all your name and configurations and stuff. but you won't have the display connection. So if you don't need to run RVS right now, you don't need to run Gazebo, just want to work on topics and stuff, you're perfectly fine. Go ahead, work on this. But if you want to use the interface, like the display port, like run Gazebo, run RPT, then use X11 servers. So those X11 servers is something that I was talking about, and how you give access to them. So Xhost, make sure that X server utils are installed in your system, in your inherit system, and then in your inherit system, give Xhost plus the IP address of the Docker. So if you type ifconfig, you will see a Docker name and IP address for that. So give access to that, like Xhost plus the IP address of your Docker. But it will still not run because you're sudo, and sudo doesn't have a IP address like Xhost. So run the final command here, xhost local :root. It will give you the root access. Now you should be good enough to run the RPT and Gazebo and all those stuff. So right now it won't, if you are using a high graphic cards, sorry, I still haven't figured out how to use that power in Docker. Like I haven't configured the graphic card part yet. You can use display and integrated graphic cards, they're gonna run. But if you have a NVIDIA graphic card, I still have to figure out how Docker can use the GPUs. But apart from that, like I don't think you're gonna run your GPUs a lot of times. For like most of the tasks, it's perfectly fine. But if something is GPU intensive, like I'm working on this, so that's like one of the part that I have. But again, since no one needs it right now, I'm not forced on it. But if someone is working on something that uses GPU, then I'm like pressure myself to work on that direction. But yeah, you won't be able to run GPU, but apart from that, it should run as an integrated graphic card kind of thing, and everything should be fine. So yeah, Gazebo might be slower. That's all I wanted to say. But yeah, everything else should be fine.
I have a doubt. So is this Docker daemon same as the ROS code? Like
No.
it should be running all time.
No, Docker daemon is just like saying that your VNC is running.
Can you just show us a demo on how is the Docker running?
Yeah, we can do that. So this is 14.0 for laptop itself because we needed a specific for these. So if you want to use Gazebo for Sawyer or something, just let us know. You can use this laptop. I was just making sure it's actually working. Okay, so this is how your okay, so I will add that. So this is tree is like a feature I use a lot, but it's in my Docker, not in my here. But so this is how the repository will look once you download it. The build folder, the Docker file, the readme.run.sh. Now you do sudo So it ran fast because I already built it before. But you know how the steps were taken. So it installed ROS Indigo desktop full, it installed X11 apps, it installed Catkin tools, it installed the other like top level stuff and all those things, like attach the volumes, X11 here again, libraries and stuff. So basically I included essential libraries and OpenCVs and all those things. Most of the things should be there, tmux, vim and all those that we want to use. So I installed all those things, and now once you build it, it will take a lot of time for you guys. For me, it was already built in my system. So now give the same name that you gave there. And there. Docker is running. So if you want to see, you can see ROS Indigo and stuff. So this part of the terminal is Docker. The right side is Indigo. Sorry, Kinetic. Left side is Indigo.
So is it like a virtual machine essentially, or?
Technically, yeah. By definition, yes.
So it's like an entire different Ubuntu which is running.
Yeah.
Or
It's technically it's a virtual machine. It's like a mini virtual machine running on your terminal. But you can configure a lot of other things that virtual machine can't allow you. I mean, even in virtual machine you can run everything else. That's what I was saying last time, that even in virtual machine you can run everything perfectly, like integration should be good enough. But there's a lot of things that you have to figure out because of the display itself. This is just a server part. So
Okay, so we are doing this so that we can actually use ROS Indigo rather than Kinetic.
so you don't have to reinstall stuff.
Yeah.
Docker is not only for ROS Indigo or ROS Kinetic.
Yeah.
Even if you are using ROS Kinetic, I'll create an image or Docker for ROS Kinetic so that when you run on this laptop, you don't install crappy stuff on our machines. And you can build on it. Like, again, the same thing. Developers use Docker to sequentially create programs, sequentially create stuff. Like I was talking about how the Docker layers are stacked. It's the same thing. So basically, you don't have to install packages again and again that you need it by default. And our system is clean enough. Also, like when you change your machine, like let's say you are working on this Docker and you change your machine, you use another laptop, you don't have to do anything else, just run this Docker. Every configuration is done.
Okay, and every package and everything.
Everything is pulled by default. So I can technically include GitHub pull up on all those stuff. Like how to pull from Git, always the master. I can include that, but it depends if you want me to include that, because your repositories might be different. So I'd rather keep it in the hard disk rather than in the Docker. So again, Docker 0, here you can see the IP address of the Docker. Exhaust plus. So, access added. I mean, ROS master is not running. Yeah, I did that too, but you got the idea that so I have to figure out some IP address changes that I have to do here, but if you do that in your system, I'm pretty sure it's gonna make sure that IP address and stuff is gone. But since I was working on this for Kinetic part, I made some other changes in the IP and stuff. But you'll be able to use these commands and run it in your system. Should be fine. But if you face that issue again, let me know. I'll update that host name and error. Like it was working on most of the system, so I'll make sure that's not an issue with you guys. But again, yeah. So yeah, that was the Docker part. Should run successfully. Like try building it. If you face any issue, just again create an issue on GitHub rather than mailing me. If that's the issue you are also facing, like let me know, because I made some changes. I was not aware if I have to do changes here. Otherwise, Ivan tried that README file. He was able to run it successfully. So, anything else you guys want to know?
So can we use the movie package for these robots?
Yeah, there is by default on the package. Yeah, you could use it.
So basically we have to copy SRC folder and Docker image and then copy it down to a computer and get all the installations done.
Yeah,
Okay.
technically, yeah, but those SRC folders are not updated yet.
Okay.
Yeah, like for each robot, I'll create those SRC folders.
Okay.
But as I said, it might take till November, and like I'm the only one who is working on the software part, and to solve any issue it takes me a lot of time, and I have my thesis going on, so it's like my side thing. So I'll try my best. If someone of you like gets very good in Docker, let me know if you want to help me out. But again, it's like a very niche thing. It takes a lot of time. Not a lot of people are using Docker. If you use it, you might be the few of the people in US who are using Docker, because in US it's not that common. In Germany people were using it, but that was also new for them. Like my internship, there were like only few of them using that Docker part. That was new. Like we were testing on Docker during that time. So it's not something stable back then. It's not stable right now. We're still working on it to make it stable. Let us know. There will be some issues for sure. Just create an issue on GitHub. And if there's an issue already, don't create again. Like I know I'm gonna try, like if there's an issue, just be patient, because I'm pretty sure I'm working. Like you can be sure that I'm working on it, because I don't want issues on my GitHub. Like, you know, it's not a good sign. But yeah, if anyone gets good at it or anyone tries to understand it, they can help me or add them as developer in my GitHub. So, but later on, we'll have a GitHub repository for the lab and upload Docker for each robot. That would be the best case scenario. Like, takes time. Anything else? So yeah, again, any questions? Please start coming here, because unless you work, you can't face the problems, or we won't be able to help you. So for you, what's your name? Girish. I'll send you, like I'll take a look at that soon. So probably give me, like this week I'm a little busy.
Yeah, next week.
By next week. But right now you should not face any problem with that. Also, just keep on checking if there's update on Docker files. I might solve that. So just keep on. Do you know forking and stuff? Like GitHub, you can fork it, or you can just like keep on tracking it.
Okay, if I fork it, if you change it, it will get updated.
You have to pull it. You have to fetch it. But you can always like not fork it and download my repository and keep on pulling it. That will work too. But any other problem with ROS, just start coming here, let us know. We are here from 12 to 5 officially. 12 to 5. Yeah. So, but otherwise also just, as I said, keep on creating the issues, work on it, come inside, when you have the access to do it. And we are here.
Well, not right now.
Yeah.
I'm still working with Access. The person who is supposed to give it to you is away this week. So
That's all.
I'll try to find alternative ways. But just if you cannot get inside, I don't know. Somebody is calling my office, and it's I'm not there quite often.
It was me.
It was you?
Yeah, today I got.
Okay.
I was
Yeah.
standing out for 1 hour. I was knocking. Nobody came.